All right, welcome. Today, we're going to tackle something that can honestly stump even the pros, the complex combination circuit. But don't worry, we're going to untangle this thing step by step and turn what looks like a total mess into something simple, something we can actually solve. Okay, first up, let's meet our opponent. This is the tangled circuit we're going to conquer together. Just take a look at this thing. Seriously, resistors are everywhere. At first glance, it's just intimidating, right? A complete tangled mess. Where would you even begin? Well, this is the beast we're about to tame. So, what actually makes this thing so tricky? Well, it's what we call a combination circuit. And really, all that means is it's a hybrid. You've got some parts connected in series, one after the other, and other parts in parallel, side by side. It's that mix that creates the puzzle we've got to solve.
Visit youtube.com/avidsystem and don't forget to subscribe.
But here's the good news. There's a really simple but incredibly powerful strategy for this stuff. It's called divide and conquer. The idea is, instead of trying to swallow this whole thing at once, we're just going to break it down into small, easy-to-handle pieces. And believe it or not, these two formulas, they're the only tools we're going to need. That's it. For resistors in series, just add them up. Easy. For parallel, you use that reciprocal formula. If you've got these two down, I promise you can solve any combination circuit out there. Okay, and this is our mantra for the whole thing. This is the absolute key. Find a simple pair, solve it, redraw the circuit. And that last part, redrawing the circuit, is the most important piece. You just repeat that simple loop and you'll find the puzzle pretty much solves itself. All right, series great and all, but let's actually see how this works. It's time to put our divide and conquer mantra into action on that messy circuit from the beginning. So, the trick here is to start from the inside and work your way out. You're looking for the simplest, most isolated little groups, and right away, we can spot a couple. See resistors A and B? They're a perfect parallel pair. And over here, resistors E and F are two. These are our perfect starting points. Okay, let's crunch the numbers. For two resistors in parallel, there's a really handy shortcut, the product over sum formula. So for A and B, we take their product, 6 times 18, and divide that by their sum, 6 plus 18. And that gives us a nice clean 4.5 ohms. We'll do the exact same thing for E and F. 3 times 6 divided by 3 plus 6, and that comes out to exactly 2 ohms. Simple, right? And this is the magic of our mantra. We redraw the circuit. We literally replace those two pairs with our new single values. And just look at that. The circuit is already so much cleaner. Redrawing is absolutely crucial because it makes the next step just pop right out at you. Okay, so what did our last move do? By simplifying those parallel bits, look what we've created. We now have new, super simple series connections. That 4.5 ohm resistor is now in series with RC, and the 2 ohm one is in series with RD. And this is the easy part. Remember, for series, we just add them up. No fancy formulas. So the top branch is just 4.5 plus 3.6, which is 8.1 ohms. And the middle branch, 2 plus 10, for a total of 12 ohms. See? Simple addition. We are making fantastic progress. Okay, let's zoom in on that bottom branch. Before we can simplify the whole middle section, we've got to clean this part up. And hey, look at that. Another clear parallel pair staring right at us, resistors H and I. All right, let's run the numbers one more time. First, that parallel pair, H and I. We'll use our product over sum trick again. 12 times 36 divided by their sum, 48, and that gets us 9 ohms. Now, that new 9 ohm resistor is sitting right in series with resistor G, which is 3 ohms. So we just add them, 9 plus 3, giving us a total for that whole bottom branch of 12 ohms. And here we go again, another redraw. And this is where you can really see the progress. Look how clean this is. What we're left with is our 8.1 ohm top branch, which is in series with this whole central block. And that block is now just 3 simple parallel branches. It's becoming, well, beautifully simple. So now we can finally tackle the core of this circuit. Our next job is to find the total equivalent resistance of those 3 branches sitting there in parallel. The DEF branch, the GHI branch, and that single J resistor. Okay, so for this, we have to pull out our main parallel formula, the reciprocal one. Now, conveniently, we calculated that 2 of those branches are 12 ohms. And hey, resistor J is also 12 ohms. So we add up the reciprocals. 1 over 12 plus 1 over 12 plus 1 over 12, which equals 3 over 12. Now remember, that's 1 over the total resistance. To get the actual value, we have to flip it. So 12 divided by 3 gives us an equivalent resistance of exactly 4 ohms for that whole middle chunk. And would you look at that? We've done it. We've completely untangled the knot. After this final redraw, all that's left is one single, simple series circuit. We've got our 8.1 ohm top bit, that 4 ohm equivalent for the entire middle section, and the last two resistors, RK and RL. We are absolutely on the home stretch now. Okay, let's get to the grand finale. It's time for the final calculation to see what all this work has led to. And it all comes down to this one last easy step. Just add everything up. We have 8.1 ohms from the top, our 4 ohm equivalent for the middle, plus the 9 and 3 ohms from the last two resistors. Add them all together, and you get a grand total of 24.1 ohms. That's it. We did it. We took that absolute mess of a circuit and boiled it all down to one single number. So what you just learned here isn't just how to solve this one problem. It's basically a superpower. You now have a repeatable strategy, a method that you can use on any combination circuit, no matter how crazy it looks at first. So let's just lock this in. The whole method boils down to 5 simple steps. 1. Start from the inside out. 2. Find a simple little series or parallel pair. 3. Calculate its new value. 4, and this is the most important one, redraw the circuit. And 5, just keep repeating that loop until you're left with only one resistor. That's the whole game plan. So you've totally mastered finding the total resistance. But let me leave you with a question to chew on. Now that you have the total, how would you work backwards through your drawings to figure out the exact current flowing through, say, just resistor F from that original tangled mess? That is the next level of the puzzle.
Thanks for watching.